But I know that we. Yeah.
You didn't have much aerodynamics.
Get the sure.
Jim, you gonna do the honors?
I can do it. I thought it was.
Oh, I don't. I think we're going in reverse chronological order by age.
Oh, my age.
Get up early in the morning.
Oh.
I think that's my legal counsel. Yeah.
I can help you with whatever. It's all good. Hang on one second. Make sure. All right. Hello, everybody. If you've never been here before, welcome to Sector 67. We do these monthly meetings. It's like a show and tell presentation from a variety of folks. Yeah, I think we got 4 or 5 of them. We'll see it. And you know, we're of course putting the best first, so it's just going to get worse as the night goes on. No pressure, Jim. But yeah, Jim's going to talk a bit about kite flying. Kite crashing really should be on here too. But
okay, well, yeah, it's then in the art of kite building or kite flying. Okay, so because it's I've been interested in passive flight technology for a long time. So balloons, gliders, kites, and so this tonight I'm just talking about a kite I made. I go on meditative walks in the morning, and I walk through prairies, and I look at the dry grass stalks, and I saw. So could we go to? So there we go. Oh, native prairie stalks. Okay, so back up one there. Right there. I mean, I look at these things and I go, whoa, that's like 6 feet long. And it's got a bamboo-like structure. I think there's one up my desk chair. We could pass it around. Anyway, nature creates these things to hold a big flower stem up in the air. And it does it, and it's relatively straight. It has a cellulose core surrounded by a really hard, fibrous outer shell. You know, it's an absolutely perfect structural thing for a lightweight strut. Yeah, so I'm going to get one of these and have it. Yeah, it's pretty amazing. So, I mean, there's a lot of different weeds that have this quality, but this one, you know, it's amazing because when it's dry, it's extremely light. You know, so that's if you just want to. And so. Because the alternative is balsa wood, basically, or carbon fiber, you know, tube. So this is free. You go out there with the clippers and you can clip them right there. So
now is this on state or federal land, or is this?
It's just helping with the clearing that they're doing already. Okay, because there's a lot of There's a lot of dogwood in there too. If you guys want to learn But no, I've just been looking at natural things and how they can be made into these passive flying objects. So that's a connection between at this, and I essentially reconstructed this. Yeah, kite. Yeah, here it is. Now this is a heavy wind kite. You know, so it's kind of heavy, but in a heavy wind, this thing is extremely stable. Until something maybe gives on it, you know. I don't know if you want to hold it. It's not the lightest thing in the world, but it is still just it looks heavier than it feels. So I took it out. Yeah, so there you go. Assembled pieces. There's 3 basic box types. Kite types. There's the quadrilateral, which is the classic kite. And everyone knows the kite. And that is an airfoil essentially. And then the box kite is what I made. And then delta wing is the third kind of form, which is this, you know, kind of like a hang glider sort of thing. So I'm working on the delta wing now, and that's at my desk. So I don't have that to present, but essentially a kite, and I just want to prove that that kite did go up, and it is flying up there, yes, at about 300 feet. and it was extremely stable. However, because it was on a very windy day, this is last Friday, when those high level winds were, it just, the higher it went, the worse it got. It was like being swept into a river, and finally something gave on that kite. So I think you can go.
You mean a river of air?
Yeah, I mean, so you got a laminar, the laminar flow starts at about 100 feet. So then off Lake, this is in front of Lake Monona, so I'm getting that full exposure. Yeah,
That's the last slide, so.
yeah, the slides were limited,
Well, now it's the song and dance portion. I think that's what we.
questions is what. All right, so on top of my desk is the other one was balloon, the concept of trying to form balloons. So that was a big balloon we made, the One Earth project. We did not fill it with helium, but, or hot air, but that would be another pass of, flight technology. I just like using natural materials. These are nylon, actually, the parts that are forming the airfoil. But you could make it out of paper, and often it was out of a paper product. And it can be reinforced paper too. So that is my limited presentation, and I'm happy to take. Oh, one thing is I wrote a haiku during the, this fabrication, and it's life is like flying kite. If you stand before the raging gale, you may learn a lesson.
Nylon, that's probably two questions. One, I just curious, maybe it's obvious you throw it up in the air or something, but like, how do you launch it? Like, I don't know, like, it's been a long time since I've been entertained my youth and or excited to fly a kite.
Yes, so stability is the key thing, because you lose so many kites by this effect, the spiraling spiral for a kite. And what I should explain is that at that point, when the kite was up there, it did ultimately pull out one of the anchors on the connecting the. So you connect here and here, and it pulled out one that released the kite at about 300 feet. The kite just starts tumbling.
This is the rebuild kite.
Right.
So this is
So
not the
I
kite in the
didn't build
photo,
this
it's
kite,
the.
okay, but it took me about an hour to rebuild it. Because the parts, in fact, I improved it because I made the parts exactly the right shape, but it was. Anyone who wants to learn how to make kites, I mean, I'm happy to sit down and share my materials. I got a whole bunch of.
I think to launch it, you stand it up on end,
launch it.
pull on it. And it
Well,
goes, so.
you actually can just set it on the ground like that and go stand about 50 feet away. And if it's over 10 knots, the wind, it'll just go like that. It basically goes straight up.
Where is it tethered? Where is it tied out of the?
About the half point of those two flights.
So two-
And then it tilts it. The front tie is shorter than the long one, so it holds it about like that. And that, I mean, this has been around for probably several millennia, this kite form. Yes.
Is there a way that if you had two strings or like say there was a sheet with two sliding strings, I don't know, I'm just imagining, probably not realistic, but if you had two different strings, let's just say holding that, right, and it causes its own issue, would there be some element of like
Yes.
steering and control? Okay, do they do that?
The fighter kites, yeah, and those often are the more of the delta wing variety. And they use two lines to control the dip. But yeah, those kites are way more, I don't think the box kite was meant for.
Yeah.
That it's a heavy lift kite. So I'm gonna put a phone on the next version, which is bigger than this one.
Your weather set.
And
Well,
I
he's looking for, if anybody wants to loan a phone, Jim.
I'll go buy a new one and then let you start that.
well, for inexpensive online video recorders, and then just take it airborne.
What about the little Pi W or something, Pi 0 W with a Pi cam or something?
Hey, we're building with sticks here, not pies, so
Okay.
it's the wrong.
Anyway, I find
Maybe I go
it's a
for
very mentally, it's a therapeutic thing to build things that are, kind of quiet and just fly, So anyway, thank you.
Thank you, Jeff.
Appreciate it.
Like the square shape instead of like another shape, like a triangle or a pentagon or.
That's a good question. I do believe that a triangular shape would work. I've never built one. There's something about the diamonds, the way, I'm sorry, these. You get two airfoils, you get this one and this one, and because of that, it's, I believe, more balanced. I think the triangular or pentagonal, you could do a 5-sided. There's something about the 90-degree angle that makes this more stable. And that's why I think box kites evolved as kind of a more reliable flight vehicle.
So 2 cylinders separated probably wouldn't work good at all then.
No, the thing is, the circles do work too. I mean, and anything that creates, there was a line in there, it was about that it's, drag, it's a component of drag that gives lift. If anything in this gives lift, then you're really just dragging this and the wind's going by. So the lift is done by the shapes and it's being inclined like this.
I would almost think if you have like 2 lampshades, kind of how they funnel in and kind of cylinder.
I'm ready, the circles are a little harder to achieve, than the faceted. Simply by, and then again, to try to make natural shapes out of natural things.
Yeah, chilling.
Well, I appreciate that. I mean, I will look into the next generation.
This summer, you'll just start tying the prairie grass with the circles on the grill.
Lines and stuff.
Oh, these were the tails, and it helps put tails on kites. All they do is they keep the bottom down. Keep it from, so if you're having this spiraling thing, it's often put another tail.
Stabilizer in a way.
It's a stabilizer, yes. Because it increases drag. That's exactly what it's doing. So,
Familiar with gliders? This kind of reminds me of this giant glider. Hoop gliders, are you?
Hoop
Are you
gliders.
familiar? Or-
I saw those while I was looking online, some of the hoop gliders. It's an airfoil. They're all forms of airfoils. So, all right, thank you.
Yeah.
All right, hey folks, Jacob here. I'm going to tell you everything I know about repairing those holiday mini lights, the incandescent version, whether you like it or not. Oh, sure. There's a little picture there, as Clark Griswold taught us, the first thing you want to check is whether your lights are plugged into a switched outlet. All right, so actually, I'm gonna start by going to this webpage and cheating off something someone else wrote. So this is the Department of Energy. They wrote up like a little blog post kind of thing about how these lights work. So really good to give like an introduction. Basic idea, of course, is that the electricity flows through the bulb and it lights up. That's kind of all this diagram is showing. Combining multiple lights into a strand, there are a couple different ways you can do it. Series, where the electricity goes through each bulb in a sequence. There's basically just one current path that goes all the way through this strand of lights here. And there's parallel, where the current splits a bunch of times. And each of the bulbs kind of have their own circuit in a way. So in reality, often what you see is kind of a combination. So this is like a series parallel light strand. And you've got these series segments. This is like 50 bulbs in series where the current goes through them all in order. But then there are multiple segments that are connected in parallel. So this would be how you'd have, generally how you'd have like a strand that has 100 bulbs. It'd be two 50 bulb segments in parallel. Let's see what else. Yeah, okay. So once it fails, my experience is generally it's a bulb that fails, and there are basically two failure modes. Let me go back here. Bulbs can fail short circuit, and the way they do this is they're designed with a little shunt material. At the base, the idea is when the filament burns out, the shunt is sort of activated and conducts. It shorts the failed filament so that current can still go through the bulb even though it's not lighting anymore. And the idea is then all the other bulbs in the segment that still work will still be lit. You can see which one has failed. The other failure is an open circuit, which you get sometimes where the filament fails, but the shunt doesn't work. And then there's no current, so none of the bulbs light and you can't see where the problem is. So that's kind of where it gets complicated. Obviously, it's pretty easy to just replace the bulb that's dark. So one of the things here is that I mentioned there are different segments, and in some cases you may need to know like where a segment ends and another one begins. It's pretty standard that you can count 50 bulbs, and that's going to be a segment. The next 50 are another segment. There's some variation, but there are a couple of other methods. The obvious one is that if you have like one segment that's got an open failure, that segment will go out. But because the different segments are in parallel, the other segments are going to stay lit. So you can usually just see where the segments are if you've got a failed strand. The other way is counting wires. So if I go back to this thing, this does a good job of showing how this is set up electrically, but like physically it doesn't do a great job because obviously the lights are all in one big long line. So it's kind of hard to picture this, but if you imagine kind of like skewing these so that the second row of lights is to the left of the bottom row, you can hopefully see that there are two lines that go to all of the segments that are like the live and neutral of the plug. They go all the way through to each segment. And within a given segment, there's kind of like a third line that puts the current through each bulb. So the idea is there are 3 wires within a given segment. And between segments, it drops down to 2 wires because there's no longer that line that the bulbs go through. So if you're looking for segments, you can look for 2 wires between 2 bulbs. The bulb housings are also look a little different, but that's kind of the way. So, okay, so like I said, the main problem where we may have some sort of non-trivial investigation is with an open bulb failure. I feel like in some sense the conventional wisdom is you check every bulb, but we can do a bit better than that by taking a given segment and doing a binary search for where the open circuit is. The idea with this is we start in the middle of the segment and pull out one of the bulbs. And then we've got a multimeter, like an ohm meter, that can tell us whether there's an electrical connection between 2 points. And for simplicity, we'll say there's a plug on one end of the segment. So we'll say it's the first segment towards the plug. And we're looking for continuity between one of the plug terminals and one of the terminals in bulb housings. And so what we do depends on whether we find that it's connected. So if there is a path, this is the multimeter would show this has some resistance that's not too big. Then we know that there's continuity between all the bulbs in the first half of the plug. That means the failure has to be in the second half. So we're going to do the same thing and split the second half of the strand in half. We'll put the bulb back in and then put another bulb. Alternatively, if we don't find continuity, so multimeter will say it's like infinite resistance, then we know there is a failure in the first half, the plug half of the strands, and we'll do the same thing on that other half. And you just repeat that, and you're narrowing in on where the problem is. Eventually, you'll be able to conclude that there's a particular socket that's the last one that has continuity. And then the bulb that you pull from that socket is the failed bulb. And then the way this binary search works is that the amount of bulbs you pull out is like logarithmic in the number of elements in the strand you're looking at. So worst case, you have 6 steps in pulling out a bulb to find at least one single failure if there's one failure. So whether that's faster than checking all of them individually depends on the case, but in a lot of situations, it's going to be faster to do this than starting with one and then just checking all. So that's a lot of text and talking. I made a little picture so that kind of easier to see what's going on if you're not super well versed in binary search. So you can see the red. I made a red knot here, which represents the failure in the strand, which we don't know at the beginning, of course. And then there's a shaded red section, which is the part of the strand we've isolated the problem to. And after one check of one bulb, we've figured out half of the strand is fine. And each time we go through, we have half of the previous section, and pretty quickly we find the bulb. Now, if you have more than one failure within a strand, you can keep doing this if you really enjoy it. You'll find through this process, you'll find a failure, at least hopefully, and you can fix that. And then you basically, if the strand still isn't working, then you've got the remainder past whatever's past that failure. You can do the search again. Hopefully, you don't have to. Okay, so now we found a bulb that's bad and we need to replace it. So what does it take to do that? Basically, my understanding is that there are pretty much 2 characteristics that we need to match. There's voltage for the bulbs and there's wattage, or alternatively the amperage that they take. And so most strands will have a little tag on it. Some of them are really nice. They say the voltage here and they say the wattage. So you basically just need to find bulbs or maybe like a donor strand that has the same values there. And you're good to go. Sometimes it's a little trickier. This label here says 2.5 volts, but it doesn't have the wattage of the bulbs. So you got to look at then the amperage of the entire strand. It's 0.54 amps. In this particular case, it's a 150 bulb strand, so it's 3 segments. We are looking for the current that goes through an individual bulb, which is equivalent to the current that goes through one of the segments. So the total amount that, or the amount that goes through one segment is going to be 1/3 of the amount that goes through all 3 of them. So we take the amperage for the whole strand, we divide it by 3. I wrote this out as bulb counts, but it's really just one strand out of 3 equivalent strands. That's the amperage through a given segment, and then the rated voltage for the bulbs. Multiply that together because it's basically a resistor. That's, I can't remember what that's called. I don't think it's ohms law, but whatever. Then we get the wattage, and you can see there's. I think this is really the same as the 0.43 watts that we saw in the label. There's obviously some variation, but I'd say they're probably compatible. So if the strand does not have a labeled voltage, which in my experience is pretty rare, you can pretty easily find that out by dividing the mains voltage that you're going to be powering the strand with by the number of bulbs that are in a segment. And if it's one segment, that's just the total number of bulbs in the strand. So like I've been talking about, it's pretty common to have a 50 bulb segment. So 120 volts divided by 50, that's how we get our 2.5-ish volts. Again, it's a little there's a little error there somewhere. But I think I've seen some strands that fewer bulbs, like 36-ish or something. It's a higher voltage bulbs. They're like 3.3 volt bulbs as well. So if you don't want to do binary search, you can use this thing instead, which I just got after this past season. I brought it with someone passed it around.
If you're clever, you'd bring all the bad strings and just pass it around to you. Oh, you can test it out.
Yeah, I don't actually have any bad strands on me. I think mostly I do this like for my parents. So they, you know, their strands are all in their house.
Is the red one for incandescent? Is that it? I have the yellow. So
I don't know. I mean, yes, this is specifically for incandescent bulbs, so I suspect yes. This thing has got a number of interesting features. There's a bulb tester, which is basically just a couple terminals that puts a voltage across, and you can just press a bulb gently into it, and it'll either light up or not. It's pretty convenient if you're doing your search. Obviously, it makes sense to check the bulbs like up and out, so you can do that super easily. But the other stuff is even cooler. There's this thing where you see inserting the this is a bulb socket on a strand, and you can see it inserting into this little slot here. This socket kind of mimics a bulb, so it's got terminals that are laid out the way a bulb's terminals would be. So it kind of connects to the strand, and when you pull this trigger, there's a piezoelectric shock of some sort that it sends through the strand, and that can so the open failures are generally because the shunt did not fail to connect to short the bulb, and this can sort of shock the shunt into shorting so that your open bulb is corrected into a short failure. So what this looks like is you plug your strand in. Plug the strand into the wall, take out a bulb, and plug the socket into this thing, and you click it like maybe a few times, and the strand will generally then come on. It will, might take a couple, especially if you got a couple failed bulbs, but then you'll just be able to see which ones are bad. And there's also a voltage detector, which you can run this thing along the strand, and it detects the mains voltage sort of like propagating through the filaments and the wires up to the point where you've got a short. So if you get the distance right and do it carefully, you can actually hear when you can hear where the short is, even if nothing's lit. So I think I've done a basic test of both of these, and I think they both seem to work. So I was kind of impressed. There's some reviews online where people say it doesn't work at all. I think it's a little bit fiddly, so it might have been some user error, but thought that was kind of cool. I'm excited to use it for an entire season of light repair. That's all I got. So I'll sort of step through these a little bit to remind you. I'm happy to answer questions about anything. I got that used for $10, I think. It's pretty simple, I think. So, I'd say it's a lot of value to
I want to say I paid like $39 for a brand new yellow one. But I don't know.
Yeah, I expect that works differently. I do not know what is involved.
And it came with extra fuses.
Any other questions, Jim?
Do you charge extra to come out on Christmas Eve?
I actually don't have a pricing model yet.
It's free for anybody in the room.
No,
Wait.
Free premiere?
They need to bring the extended.
What kind of light setup are we talking about here? It's like one of those magical
Well, do you recognize this picture? No. We don't go too crazy at my parents' house, but there's railings that are wrapped with lights, and we've got a couple of animatronic deer that have little lights wrapped around them, and there's some lights on the house. It's maybe overkill. Anybody else?
I mean, any device with a quick fix trigger that you can just keep mashing, that seems well worth it.
Now, how do you program them to blink like LEDs then?
That's out of scope of this talk, sorry.
Does that, so that, I missed the teaser, does that red thing actually puncture the wire and tusk? Or
This
not?
thing?
Yeah,
No, so it's basically just impersonating a bulb to tap into the circuit the way a bulb would connect. So it's just two metal terminals in there. It's, you know, at least it shouldn't damage or change the thing in any way, so. Yeah. All right, you're on.
Thank you.
So I can drive this end if you want. Or we're not even, we're gonna drive.
when. So in this, I am a sports player and bought the Christian quarter. Years ago, I was several of my siblings. And of course, we formed a group. Bought this thing for $120. It came in a cardboard box. It was a good cardboard box. It took duct tape very well. And finally, it was the end. So I had to replace it. This is actually a talk about how Sector67 tools helped me out in my recorder playing application. So anyhow, I drew this thing up and cut it on the laser cutter over there and produced a box. We have a picture of it too. The back of it hinged, and I put a few quarter rounds in there to reinforce my smaller parts. But okay, so this was a good recorder. I don't run a lot that's the years. But it's inexpensive. It does not have the second key down here. This is the F recorder. Below it is F. It doesn't play an F sharp. Also, on the upper range, it will go to middle C, but nothing above middle C. And when I joined a recording group here in Madison, it's nice to play higher or lower notes. We had to play those in some of our pieces. Well, that group had another recorder. A nice recorder, and it's got lots of keys here for the lower notes. So this had the F sharp key, as well as a G sharp key. So that was good. Then also played the upper notes. And this one, I suppose we can get a little tune here or a little bend. Okay. Start with this one. Here's the lowest note. Up to higher and the highest note. The other recorder would only go that high, it didn't have the higher notes. But I always had difficulty playing this because this wrist here does not want to, get down and get these little notes here, and it's difficult. Well, I know from my previous recorder that if you have a bogle, something to go up here, then of course this position is you can play it much easier because you have it in position. So I decided to make a bowl. I talked with folks, our local
music store people, repairmen. And he says, well, if you're gonna be bending brass pipes, you're gonna have to fill it with lead because they'll just kink. And he said, there's a special lead you put inside these, and it's the kind of lead that expands as it solidifies. It puts pressure on the outside of the or the inside of the brass tube. So I found that, and I'm sorry, I wish I could tell you what it was. I'm looking for it on the internet. What I have left over is in storage right now. I can't show you what it is. So not only does that lead expand when it solidifies, it also has a very low melting temperature below boiling point. Once you get the lead in there, all you have to do is put it in boiling water and it'll just roll right out. Now you may be thinking that, well, there's a problem. You're putting lead in a brass pipe, you're taking it out, and then you're taking that brass pipe and putting it against your lips. So the solution for that is to first coat the inside of the brass pipe with regular olive oil. Just stuff from the store. So anyhow, next slide. I made a couple of them. The wood mouthpiece I turned here on the lathe. After drawing up, something I thought would look nice and 3D printing it. But of course, these are turned on the lathe here, the jet lathe. And that's only part of it. The cork, I had folks from Ward Brat put that on, the repairman there. The other part to this Vogel business, you had to put a different top on. Next slide. And that was also done on the lathe. I decided to have the people at Ward Brat drill the hole in it because he would be matching the cork with the hole, and that work would be done by him. And then the brass is simply a brass pipe. It's from Milwaukee all metal. Buy those pieces of it, and I turned that on my my lathe at home, the Uniman, little tiny 1-foot lathe. So I made 3 of them, mostly because one of them, the hole got too big, and it wouldn't fit tightly on the top of this. But in the end, I had a recorder now for the Vogel. And of course, that does solve the problem of the wrist down here, because now it's at that height. And I enjoy playing it an awful lot. I thought, well, maybe I should get my own. So since I already had tops and Vogels, an extra one, I thought, well, let's see if I can find the exact Mac model. And I did find one over in Britain. And they sent it to me this about a month ago. I got it. And I was playing it, and well, okay, first of all, my top that was made too big, that fit on this one. So that solved that problem. And still got an extra one. So I suppose I get a third one. Wrong one. Yeah. Okay, so there's a problem here. So we started looking at it, and so, well, it's supposed to be identical recorders. So what's the difference? This one was supposedly overhauled, so it has a real nice opening on the upper one, which is this one. And the lower one, it's not such a nice opening, it is smaller, it's curved, I don't know, but it plays better. Also, we go to the next slide, the opening on the, where the air comes out. On the right-hand side, again, it's larger and smaller on the one from the church had. So, well, there's the issue of having an opening that's too large. Why don't we just try filling it with something? So the British one, the measurements were on the top, church measurements are there, the difference is between there, or at the bottom. And it came up with a drawing then for next month's slide, something like that I needed to put inside. Pretty tiny measurements, 60 thousandths on the sides, kind of keep it from flopping around in there. And 60 thousandths down here on the bottom. Okay, the opening for the British one was 81 thousandths. And down here was 35 thousandths. Well, you can't put that on a 3D not a filament one. But we were setting up a polymer resin light activated polymer resin printer here. And so I made so far a total of 3 inserts. Some difficulty. They were perfect. On the far edge there, you can see it's well, I'm even trying to get this polymer printer to do more than I can, because I was told that the pixels on these things are only 35,000. Actually, the measurements I got on this when I took it, if we go back to the other slide, they're in blue. I got 17,000 here instead of on the wall, instead of 6,000. Here I got 39,000 instead of 35. The passageway was 25 instead of 32. And the solid part was 14 instead of 6. And on the top, you kind of see the same things. Actually, I did get the 81 thousandths right at the start up here, when it started printing. But it quickly dropped down to like 76, and it was, you can see on the plastic ones on the next slide, it's a little rough in here. But it finally picked up. So I stuck this in the passageway. The wrong way, actually, I put it so that it had air pushing out or pushing more to the outside. That didn't work. So I turned it around the other way, and then I was starting to get good results or better results. I printed another one a little bit longer. There's also on the upper side of this, and this is just a matter of the printing part. This has a little bit of a lip here. It doesn't start off nice and smooth, but that allowed me to grab this thing with my thumb and pull it out if I had to. So that was nice. Okay. So let's put this thing. Yeah, it sticks out a little bit on the top. You know, I can grab it and I'll pull it out. That was much air. I got one. I suppose I could try to optimize this somehow. I don't know what parameters I'd have to change to optimize it. But if this played like this when I first got it, I would have been happy with it. So it's good enough. So, any questions?
Yeah, of course.
So Bernard, just curious, so is the essence of the numbers is you printed it slightly oversized and then sanded it down to dimension, or?
No, so I guess I didn't realize what the limitations of the printer were, or theoretical limitations. So, Jerry.
That's one of the bad ones. But they're really small.
Yeah, okay, sure.
Maybe.
Was it that it varied? It wasn't consistent, like there were some spots where it started out closer and then it was a little thicker or thinner?
These edges are worth having because the edges are like, they're very, very small. I'm sure a form printer, a small mouse printer would print better.
Yeah.
What brand?
What brand model
It's
printer?
just a cheap
You can open it
Anycubic.
up if you want.
It's nothing special. It's an Anycubic, it's nothing special. It's a cheap one.
Yeah, we started out with the Anycubic. I guess we were having,
Okay. And
yeah,
it's orange.
that one was released high,
I-
and
I-
it was not printing as we wanted, it was sticking at the bottom where it started printing. The spindle one, but it was getting steps. And so we set up the Elegoo Mars, and these were printed on that. Had good luck and printed right in the center of the bat where the polymer was.
Talk to me afterwards. I have a little nicer one. If you want to try something, I'll do that.
Yeah, okay. Thank you. Yeah,
I got a question about the picture of the ends with the holes.
these.
I think that's the end of the actual install.
Okay, yeah, all right, sure.
So you've got a long hole that you're inserting this piece into, right?
Yeah.
What's the other thing on the other side will notch?
That's to give some,
Really,
get some relief, yeah, because that's a different piece of metal. A different piece of wood that gets trimmed and pushed in there. And it can be knocked out when they repair these things.
this is an insert into a piece of bamboo, and so
you
this
can't-
is to give access.
Yeah, you can't stick a rod in here and knock that centerpiece out.
Which is the other way to fix this is we could have like knocked the whole thing apart and glued a block in there and then redone it. But the risk was we had no idea what it was gonna do. So I didn't want to send Bernard down the path of like, rip your entire instrument you just bought apart, hoping that it makes it better.
Yeah.
So,
And people at the local music shop, the word rock people said, we don't do that kind of thing. And they gave me some Boston repair shop, so. So yeah, I thought, well, I'll just experiment myself.
How is the oboe related to these instruments? I mean, it looks, or the bassoon, I'm thinking.
Yeah, the bassoon and oboe, they're reeded instruments.
Okay.
So they'll produce a buzzing to start their sound out, and then it goes through the instrument. For a recorder, it is simply a whistle. So it's just air that goes through it. So
Is there a song and dance for this presentation?
not just this.
For you to take it too long, like, I don't want to run you late or something. What's like the history of like when this was like a popular instrument or something, or what it was used for?
Renaissance, the very early Renaissance instrument. Was made for wood, and there's many pieces from that era. And well, they're still playing. People are still writing pieces for today. I don't know if we Michaela Petrie, these are just modern day. So I have pieces written for them. Bach included recorder in his music. So it's been around.
Why do you think recorders fall out of fashion now?
Oh, no, they're not. They're not.
You're still gonna say recorder and it's
Well, okay, they aren't a terribly loud instrument. But Europe has many recording ensembles. Here in America, there are a few too.
I was gonna say, this
like
is
an
a high
electric
time.
guitar, right?
And every summer, University of Wisconsin has a week celebration for recording music, you can come in, take classes if you want. So,
Any other questions? Jim?
So a woodworker making these was screwed up and didn't have a resin printer. What would the fix be? Would they glue a piece of wood in and then carve it out again?
well, right now, I mean, I am not a professional recorder repair person. But if I was to do something like that, I think I would probably, make a piece of wood, the dimensions of this 3D printed piece. And just, slide it in there and kind of glue it into place.
Yep, okay, yeah.
Which I think would be the easiest repair.
The trouble is that it's hard to trial. It's tough to make this little teeny tiny wood scrap and try it.
Yeah,
Versus
yeah,
the
yeah.
resin printer can reliably make, high low.
Can you get back down?
Well, we were talking about machining something.
Yeah.
So we could throw it on the mill and you can machine wood.
Yeah, I mean, they might do something like just hit it with a chisel, right? And just shave a
Yeah.
piece and then, sandpaper to get it to.
Gonna say the Japanese planers are paper thin, so.
Sure.
Yeah, it's to be clear too, that end cap knocks out, so you can actually knock the end cap out to get working space and then
Yeah, and then
get in there.
glue
I
a
would
piece
think-
on that surface.
Oh, you mean the.
The end cap comes out, yeah, you could punch that out.
What do you guys like take that out and remake one of these? I mean, that'd be the ideal, but you were just, it was risky.
But in this case, it's not this was the problem, it was this.
It's the outside.
I had to
wall bamboo.
build up this side. When I had
Oh,
this
and you
turned,
couldn't just fill the
yeah,
inside.
when I had this turned the other way, there's too much air going out and not over the whistle part. So I turned that around and then it was shooting more towards the whistle. And that's what it spoke finally.
Right, Bernard's doing a concert afterwards, so just stick around and he needs accompaniment though, unless he's got a drummer and a singer, he said no, so.
The group is playing Sunday, so. We are, this is at church and we're in the middle of Lenten season now, so. It's a choir piece, but of course, we're just playing with instruments. But the words are very confessional. Being the Lenten season, so I don't know. The music is nice, so.
You can work on those lights, like all the festivities.
We got a fog machine upstairs, so.
Okay.
Alright, thank you, Bernard. That's the street. Jerry needs to start wearing all this. Let's get it right.
There we go. What's up, nerds? Yeah, so this is my third update I've done on this project for y'all. This project has been my very long running project that I've worked on this for probably about 2 years at this point. So what am I trying to do? So I am trying to take D&D in person, try to mix it with virtual tabletop systems. Because I had seen where people would do put the TV on the table, do really cool interactive map. I was like, that's really cool. Would it not also be cool if somehow the TV knew where your mini was? So then you have I'm in this dark area, and as I move my mini through the area, then it starts doing fog of war, expanding, you can see more. So I'm trying to mix the two. So the approach that I am currently working off of is the virtual tabletop system knows where every grid location is. But I'll talk to it and then I'll play it again. So it knows where everything is. And so I have a basically just a light sensor sitting in a base that is looking down at the TV. And then if the TV can like flash in some way, it can convey information to the miniature. At which point the miniature over some side channel, I'm using Bluetooth, can communicate to the virtual tabletop. Hi, I'm mini ID so-and-so, and I'm at this location. With this, I'm literally sending a binary through this. So each location is sending its XY coordinates, as well as a checksum, so it knows, did I receive this information correctly or not? I've been calling this the duck hunt approach. If you remember old duck hunt, you pull the trigger, the screen would flash, and somehow it knew that you had shot the duck or not. And basically the trick was, well, if we make the screen go all black, then we show like a white square in one location. The light gun is nothing more than a long tube with like a photoresistor far end of it. And so then it looks to see it's, that relative brightness shift, does it look like you shot the duck or not? So that's how I've been referring to this approach. So I have hardware. I got hardware made. The thick lines on this are 1-inch grids. So pass things around. That is the one that's fully populated, and then that is a non-populated one. Pass those around, please. On the back, you'll notice I put a bunch of headers on. In theory, you wouldn't actually populate most of those except for the one that's powered. But one's like a debug header, and then one is actually a bypass header. It's a very complicated board. It's the most complicated I've ever made. Didn't know if I was going to screw it up or not. So I actually included some jumpers on there that are naturally closed. You can cut those with an X-Acto knife, and it'll make it so certain parts of the board will not activate. And then you can use the backup bypass header to then drive them with an external microcontroller. I got this made, and it takes firmware, which is exciting because this is not a board you're just buying. That just like somebody else has made sure that it works. I put it together, and so there's always a chance that I screw something up. I have written firmware to test all the components at this point. So the light sensors and the inertial measurement unit, Bluetooth are all working fine. It also takes the firmware, which is the important part. So yeah, pretty cool part for the project to be at. Just a quick overview of the hardware that's on there. So this is our NRF52. This is the main microcontroller. What's really cool about this is, so it's a very low power microcontroller. The power budget for this thing is a coin cell battery. It's a CR2032. It's the one that looks like a quarter. That does not output that much power, nor does it have that much capacity. So very low power, reasonably power microcontroller. I think it's still like 64 megahertz. And this one that I'm working with is 512 kilobytes of flash, which is just huge in microcontroller land. And then it includes built-in Bluetooth low energy. It might be able to do classic. I don't quite remember. I'm doing Bluetooth low energy because I don't have that much data to send, and again, low power. Light sensors, I actually have 2 on there. The idea of the second, so when we send that information, that tells us where we are, but it doesn't tell us how we are rotated relative to the screen. Because I had in my head, it's like, what if you're playing more like science fiction game, not necessarily D&D, and you have like a flashlight. It's like, if I was to turn my mini, maybe I want to like illuminate parts of like the room I'm in. And so by having the 2, then I can put a gradient between the 2, and then I can look at the difference, and that can confer some level of rotation information. And then the IMU, this one is, so this is useful for, one, I can do gestures. So maybe you walk up to a door, and then I just make it so that way you double tap on it and like can open like a door or something. The primary why I put it on there is it's a way for me to sense I picked it up, I moved it, and I put it down. Now I need to trigger this like relocalization. So I have this way to detect that. And then who doesn't like lights? The status lights can be useful, especially if you're doing like sun or whatever, being able to flash lights in some way. So yeah, so like I said, I put in a bypass header in the jumpers, that way if I screw something up, I had an out. They're not, this particular one, I think in total, it would cost me somewhere in $150 to $200 to have 2 copies of it made. Part of that is part selection. So I have in here certain parts in JLC PCB, they do assembly services. Certain parts will bump you into their more expensive process. The IMU that I selected bumps you up into the higher process. And so it's expensive enough that it's like if I screw something up, I don't want to have to like, oh, well, let me pay another $200 to get these things made with my one little minor update. I'm mostly trying to test, some level of integration. And then I just think it's interesting that they don't make it as obvious on their website, but JLC PCB will do global sourcing for you. And so if you can find the part on like DigiKey, but they don't have it in their fab house, they will generally do like the import for you. It will stand out the time, and start to finish of like getting these like assembled and like through the process was almost like 2 months. If they have everything in house ready to go, it can be like 2 to 3 months. So it will slow things down, but they will place the parts for you. So anyway, what if we just ditched all this, right? So last time I recall at least somebody saying, why don't you use, some sort of camera that's looking at the screen, looking for like patterns, based on these patterns, somehow we can say this is where we are. And I was like, there's no way, like I got, I don't have the processing power. This camera has to look at something really, really close. My budget for power is like nothing. No way, no, right? Like, where would I find a camera that can do this? How do optical computer mice work? They are cameras. They are very low resolution cameras designed to look at something very close up, and designed to be very low power. How many times do you have to change the batteries in your wireless mouse? Almost never. So how do we use this? It's a little bit of a delay, so I'm getting my timing on everything. So yeah, has anybody ever heard of a live scribe pen, or seen like those pens where it has like special paper and you can like write on it and somehow it like instantly digitizes it? There's no scanning process or whatever, you just write, you can load it into your computer, and somehow it's everything that you wrote. And the trick was that that paper has information encoded into it based on the positioning of those dots. And I don't know if my mouse shows up now, but right under like the camera section, whatever, basically that where the dot is pushed is some level of information. And the trick that they actually use is that multiple rows of those dots together encode some number. That number is part of a very large non-repeating sequence of numbers. And very helpfully, the rotations of it, like 90 degrees or 180 degrees, are not present in that pattern. And so if we go scanning, we don't find it, we just rotate 90 degrees until we find it in the pattern, then we can localize. The implementation by Anoto, the company who came up with it, their implementation can find, millimeter resolution in like all of Eurasia. If you have like paper the size of Eurasia. So, seems pretty good, right? Helpfully, this patent expired last year. So if I do try to commercialize it, that patent's out. So what can the pound sister see? These are some dots that I put on the transparency. This is my second pass round. I actually do have 2 pass rounds. Let's start passing around. I got these printed. So the paper that I'm passing around has the dots in the Anoto pattern encoded onto it. So it actually has the location information. But not only can we see like the microdots, you actually can see the pixels on the screen. I'm not convinced that this is sufficiently useful because the sensor is very sensitive to the being in and out of focus. And so I'm like, I don't know like different screens, but I'm assuming that there's probably some variance in like flash thickness. Or if you're like doing this for real, you might have like a small screen protector on there that would push it away. And so I'm not convinced that I would want to do the direct pixels on the screen. But we can put this pattern based on like a transparency. We use that as like a screen protector on the screen. You probably wanted a screen protector anyway to keep the TV from getting scratched up. So I think this is okay. And then I tried to basically use it for localization. I tried to like by hand, like try to draw out. I don't know how well this is showing up. I should pick a much brighter color probably. But you can kind of see how on the grid, those dots are kind of pushed in and out. And so there's some level of information. I have not written the program that actually parses this, at least from the visual. I have a program that'll do it if you copy it in by hand. So yeah, I went as far as getting hardware and whatnot. Why would I switch? I think this will work way better. With this, the screen never flickers, right? We're not conveying information from within the screen. Basically, the nature of the screen itself with the screen protector has all the information I need. So it should just be you take your mini, you place it on a screen, and it should instantly, as far as human perception, know where the mini is going. Last time I was talking about how this whole thing of trying to use like machine learning with the inertial measurement unit to like when I pick it up, can I move it and like use that to try to like kind of guess where I ended up. We can just ditch all that. We don't need to try to figure out this hard problem. We can just bypass it with another hard problem. And then like I mentioned, one of the constraints in my last presentation I was talking about like trying to like minimize external hardware. Yes, I am adding something, but I think the screen protector was already a thing you probably were wanting to have. So I think it's okay. It's okay probably for me, and I'm the one who decides on the project. So whatever. But yeah, otherwise, that's my thing. So just I started trying to write more on my projects. So last presentation that I did here is the most recent post that I have on the blog. I basically been working my way through trying to do it on a regular basis and be it as a habit for me, not as a I did something real fast and then like just call it good. But yeah, any questions?
I think you probably explained this and I was zoned out, but if you're using the pattern to identify the location, you then need to have that be visible to the piece, but also have the screen still be displaying something that looks right? It's displaying like a terrain or something.
Yeah, so with it, there will be like initial like when you put your screen protector on the TV, you would have to do like a quick calibration of like put the mini like here, and you put the mini there, and be like maybe put it on like the opposing corner, you put it there. That should be enough to basically calibrate it. So then the mini would say, I am at these ultra precise coordinates, at which point your module for like Foundry would have to say, oh, these ultra precise coordinates sit within this much larger box, because it knows where the boxes are.
And that's that transparency pass.
Yeah,
Without the grid.
Yeah.
How are we collecting payment for the IXN?
Yeah, right. I just think it's cool, like with it, it's like you can see through it just fine, and then you throw like anything resembling a complicated background behind it, and it just fades away. So if you have a really white background, you can see the dots and just kind of like a fuzz on the screen, but if you have like a dark scene or whatever, it disappears.
Again, I might have zoned out too, but so
Really, I did.
how I did better my presentation. Great presentation, actually. How precise does it capture the position when you put something down?
So this is the dots themselves align to like I think 1/4 of a millimeter, but that's where the dots are. And so you can then be like, well, this dot, I know this dot to a millimeter precision or where it is. That gets me to some region of a millimeter. But then you can look at multiple dots and be like, I know where those must be in this pattern. You can get sub-millimeter. We do not need this. I know for this application, but it is there.
You want to know if someone moved your piece.
So we were talking about like the double tap for like a gesture. I can actually probably do that without having the IMU on there, because if we can see things to this level of precision, that little tap motion would be a jitter, and you could potentially action off of it. So, and so we're shaving down some hardware for a certain level of complexity, but we're getting other complexities, so maybe it balances out. Yeah.
So what is like at least with your old like model, what is like the battery life frame for the minis?
Yeah, so I'm trying to look at what I think the power utilization is. I think the answer is literal weeks of it being on, like actively in use, and then standby of like a year or two. I don't know because I haven't like done it for real or set up, but I think the answer is a really long time. It's one of those where battery life is either really bad up to a certain point where you just make a bunch of decisions and design decisions, and then suddenly it becomes way better than I need it to be.
So, a lot of them.
Hang
Hang on.
I didn't see a hand up.
Yeah, exactly. Look at there.
I was just curious,
Wait.
how do you mount these minis, like?
Yeah, so the one I passed around, it doesn't have a, so I initially was gonna put the battery pack basically, or the coin cell directly attached to it. Problem is that we actually need a little bit of standoff for the Bluetooth radio signal to propagate, otherwise we would just create a shield and it would only transmit to the screen. So there's a little bit of standoff. I'm just gonna leave the battery exposed because it's a steel case, which is magnetic. So if you just slap a small little magnet to the bottom of your mini, it'll just snap to the base.
So it's like this thing without the headers. You take the headers out.
Yep.
You can just put stuff at the bottom.
Yep.
Jim?
You want us?
Okay, I have a two-part question.
Oh, no, I think so.
First, are you using 2 mouse sensors to do orientation as well?
No, so one, as we mentioned, with the fact that that pattern is unique amongst its rotations as well, then that immediately tells us which 90-degree rotation we're roughly at. At which point we know that the grid is still like, a horizontal grid or whatever. So then by looking at the pixels, you can then look at the difference of, the couple of degrees of what that line is that traces like across. And so we should be within, a degree or better probably of being able to determine rotation from the picture itself. So we get rotation from a single mouse sensor.
Gotcha. Okay, so the second question is, I imagine a fair amount of the mouse draw is the illumination on it.
Yeah.
Can you use a television to illuminate your grid pattern?
So if you use the TV, you have to get it really bright. The thing that I think people don't like, you look at a TV and you're like, this is bright, but it's bright in aggregate, not bright on a per pixel level. And so this was like an issue I was having with just the light sensor alone with the original design.
Yeah, okay.
Is that I had to generally have a brighter brightness shift than I really wanted, because it's actually really hard to see with electronics without like full lens assembly to pull again in aggregate. So yes, it's a fairly high current draw, but the mouse sensors, they actually do have various sleep modes. And so you can actually, there's actually like a motion alert pin or a detect pin that will fire an interrupt saying, hey, I have seen motion. And in one of its lowest power saving modes, it's like responsive to 200 milliseconds. So after 200 milliseconds of it being moved, it would tell you about it, but its current draw is like 10 microamps or something to do that, because it's only turning on the sensor, once in a very short while.
Sure.
So I think we're still good on power. This we're changing stuff up, but yeah. Chris?
So, since these are all Bluetooth devices, how do you manage like having that many Bluetooth devices connected to your computer? Like, I guess I don't know how many minis you usually play with, right? But
So luckily, shouldn't be that many, right? Is that it's you would only have players probably having many. So you maybe have players and then maybe one max with like a party token, because maybe as you're like exploring an area, you don't really need everybody to be moving. It's like you just have one. But with why Bluetooth low energy is so as low energy as it is because we're sending very small amounts of data, and we're and it's a very, very brief transmission. So part of why like my power budget ends up being so good is that it's only waking up to send data for like a couple milliseconds, then turns off for a much longer period of time. And so that alone, we basically have just like a lot of good time sharing that we can work on. I think Bluetooth has some level of like multiplexing. I don't really know. I can't imagine an environment, even in a very loud environment, where they would not be capable of transferring the information in a reasonable time frame. Because even if that's a trigger retry that sees the collision in the air, it's like, still going to be faster than your eye probably. It's going to know it's
a little more complex than what I was asking. It's like I might be like I might not understand like how to specifically use Bluetooth, but when I think of Bluetooth, right, it's like, you have to manage Bluetooth devices on your computer. Like, would each of these minis be like one of those, or is it like, do you use like a different
So-
system?
Yeah, so,
Worst case, you just plug in like 4 USB adapters. Fine.
yeah, no, because it's so. In software, you can do the pairing, so these will be like in the non-paired, like non-encrypted state, because I don't need them to be encrypted. And then with that, I need to actually go through a pairing step with them. So they will advertise basically they can advertise a name. Like how like a Wi-Fi point can advertise a name, Bluetooth, the low energy can advertise a name. So I can use that to find them in like a room. And then basically they throw like an endpoint, and then I can call out to it and be like, hey, who are you? And then where are you? And that can be conferred via through the channel.
I think the key maybe is that the software can do all of this, right? So like,
Yeah,
it wouldn't be on
so
your
this would
computer,
be basically visible to you as the user, other than either you might have to use a program that I distribute, or Chromium-based browsers can actually talk to Bluetooth devices directly if you give it the permission to do so. And so you could potentially just load up Foundry Virtual Tabletop in the browser with my mod, and that itself could talk to the Bluetooth devices without you being able to.
Only Chrome or other?
Unfortunately, yeah, only Chromium browsers are the only ones who support. It's basically one of those experimental APIs that nobody knows if they care to support in the long term. And so Chromium browsers are the only ones that implement.
Are you saying you're only sending the advertisements? Essentially, you're not actually connecting to the individual devices?
So
Or
if you are in the connected state, you're still not, if it's Bluetooth low energy, the connected state is basically an agreement that I'm the one who's gonna talk to you, and that's about it. We don't have to like constantly, I think there's keep alives. When it's like 1 keep alive per second, and that keep alive is like 1 millisecond of transferring.
I'm saying with the issue of having multiple devices connected, multiple dealers.
Yeah, so they all act as basically servers, and then your laptop is the client that connects to them. Because of the size of how much space I have on the microcontroller, I think I can only support 1 connection at a time. But so it'd be your DM's laptop or whatever is the one that's doing the connection. Like nobody else is probably running a laptop for this. I feel like I'm not answering the question great, but.
So then for clarity, are you saying that each player, like they're gonna have 1 piece, right? The player has 1, I'm sorry.
Yep.
We got, don't play D&D.
Funny enough, I don't actually play that.
So that every player is gonna have their own laptop or a device that connect.
No, the intent, so with this, I'm trying to not break the group immersion of we're all sitting at a table trying to do a thing. With the like TV on the table, I didn't want to be like, well, here everybody has a mouse to control their like person. I want it to be, so your interface to the system literally should generally be nothing more than I have a mini that I can move. And then the DM might be running the special software or whatever, but you as the players to the table, just minis moving around the table, and that is your interaction with the system. You don't have to have a computer, you don't have to have your phone plugged in anything, you don't have to be running some special software yourself.
So have you used this already with your, has it actually run it?
Right here.
Right there.
With
No,
multiple-
the closest I've done is I ran a game where we put the TV out on like the table, but then they had like a party token that they would move, and then I would with a mouse move it. And it's kind of trying to validate, is this idea cool? Before I spend a crap ton of effort on it.
I just did location tracking with BLE for our cats, right? So that, we can turn on a vacuum in a room or something. It was shot collar, yeah, it's nicer to scare them with sound, although maybe traumatize them, but yeah, been doing that in this way.
You need a millimeter accuracy in your house, but also willing to throw a bunch of printed transparencies everywhere too. Yeah.
I was just curious, this might have been answered on the previous presentations that you said you've done, but so like when you do this, like what's your main intended use of this? It's like is it mainly just for like when just in person, or is it like is it meant to interface with like also online playing, allowing people to see the board? Like I'm just curious.
Yeah, I am primarily intending this for as an in-person thing. However, since we are leveraging a virtual tabletop system, which is traditionally designed for everybody as a remote play, then you could mix, right? Is that everybody at the table maybe uses these to like do their updates and they're playing that way, but you have your friend who couldn't make it and because he's traveling, and then he would be able to like use the Foundry in its normal case, or any virtual tabletop system, and it's the normal way of they're just dragging and moving their person around via like the web page that they pulled on. But everybody else is doing the token. My primary is we're all in person, but I want to do really cool like dynamic maps with dynamic lighting, fiber work feeling.
It's just kind of like a follow-up on what is, do you plan on like also doing like a bunch of software for a tabletop, or are you just gonna provide like some way to for the tabletop interface, and you just like give an API and that's it?
Yeah, so I'm the extent of my research so far has just been looking at the API designs for Foundry specifically, Foundry Virtual Tabletop. But I think most like the reasonably popular ones all have APIs that should support this. I know Foundry does. So I would only be providing like the mod that you would load into Foundry. I'm not providing virtual tabletop software. That's a whole beast. People build entire businesses around that, and I am not interested.
Thank you.
Yeah.
Two quick things left. So, Heather, you're up.
I pass around to go.
They're on my desk.
Okay.
They're safe.
Well, I only have 2 of them, so.
Where's your thing? It's another seed swap. I was on here. What's it called? Seed swap.
Hi, everybody, I'm Heather. Well, 3 years ago, I went to a seed swap event with some friends and thought this is really cool because most people are like me, you have way too many seeds and all your seed packets say you should use them in 1 year, which isn't true, but that's what they all say. So we are hosting the 3rd annual Sector 67 Seed and Plant Swap, not this Saturday, next Saturday, on the 15th from 11 to 2. We just set up some table. If it's nice outside, we set them up outside. You can bring, I have full packets that, some seeds have been used and are gone. You can also, I just take envelopes and cut them up into little ones and then label them with what's in there and just put a couple seeds. You don't need to empty a whole packet. Just a way to share, swap, and many people might be having their victory gardens again this year based on grocery prices. So if you are interested, you're welcome to come. You can also bring, if you have any propagates that you might start at home. So taking your plants, making new plants, or if you have house plants, I am like a plant hoarder around the building. So Chris always loves it when we do this event, and then we get like 10 new plants. People leave them, and it makes me happy. So if you have plants you want to bring, you're welcome to bring those. If you don't have seeds, still come. There's always a lot of seeds left over. You can go through, take whatever you want. There's no like, oh, I brought 2 seeds, so I only get to take 2 seeds home. Take whatever you want. After the event's over, I always take all the leftover seeds, and the Madison Public Library also does a free little seed program. And so I take all the seeds over to the library, and so they still get used by others in the Madison community, even if people from the neighborhood or sector community don't want. Any questions? All right, I'm done.
All right. As far as I know, there's nobody else to present anything. I just got a couple quick pictures. I was asked by Tormach here in town if they could test something on the laser welder. So we have this thing in the welding shop. It's a 1500 watt fiber laser. So this bottom blue and white thing makes a fiber optic light source that is 1500 watts and a little teeny tiny cable. It's invisible light to humans, can't see it, so it'll blind you permanently forever, and you won't even see it coming. So that is the bad part about it. The good part about it is that it is able to deliver lights into a weld into a really, really small, like thin thing. So this is a piece that I welded together. The weld is this little tiny line down the middle of it. It is here, really, really, really small. I guarantee somebody's gonna break that in half. I don't have any hard feelings about it, so whoever breaks it in half, feel free. I don't know how strong it is. The other thing then that the laser is able to do is to weld ridiculously thick things to ridiculously thin things. This thing's really heavy. Again, probably isn't gonna break, but you know, maybe it will, maybe it won't. And the other thing I should warn you, some of these things are kind of sharp because they're just stock out of the wood or the welding shop. So this is what the laser looks like. So this is your ray of death on here. So the light source comes out the middle. This orange hose is just carrying a traditional wire, which is added in as filler material. And then the other really cool thing is the laser can reach down into areas that you could never really weld by a conventional process. So when you weld with the regular process, the electricity is melting the metal, and the electricity wants to jump to the closest surface. So it really doesn't like to go down on a crack. This thing's full of all sorts of spiky things. So I'm gonna set this on the table if anyone wants to look at it. So we don't kill additives here.
Thank you.
But yeah, hospital bills are expensive. That was really all I had. So we're gonna test some other welds for some product. The interesting thing with this is that it's able to weld really, really quickly, like much quicker than even a MIG process. Because it's only delivering energy and only delivering filler material to where it needs material, and it's not allowing it enough time to really draw energy away from the weld pool. So it's kind of cool. Then we have any questions? So yes, of course. Sorry.
So is it like made, so it's got like a feed of the filler material?
Yeah, so the filler material is coming in underneath. So that's this small wire here. And then it's adding the energy coming out of the cone here. So you actually see this is the weld distance. Here, so the cone of light's coming out, it's melting the tip of this filler wire on the end of it.
And it automatically feeds it, like.
Yeah, automatic meaning I set the feed rate, but yes, otherwise, yeah, it's just feeding it. It's naively feeding, so it doesn't know what's going on.
How is this compared to MIG or TIG welding, like for a learning curve, like the get, like what you did on that fine little piece, like that looks like that was probably a fun one to get the settings right.
Yeah, once you set up the settings, it seems to just, as long as you can pull a straight line, because it is you moving it, it welds very well. If you're not concerned about, melting your face or losing your eyes, it's no big deal.
What do you use for, is it a regular?
No, you can't use a regular welding helmet because the welding helmet doesn't block enough of this. It's 1064 or 1070 nanometer. So it's completely invisible to you. But it's really bright where the plasma is, where it's vaporizing. So no, it's a specialized welding laser face shield. The real ones sold in the US have an aluminum face and then a little screen you can see through. Because if you get reflected light, it'll melt the face shield. It's pretty cool. Kind of a problem.
I don't think it's.
So I just make sure that I don't reflect the light in my face. So you do, in all seriousness, have to be conscientious about what this thing's doing. Because if you're bouncing it into essentially a prism and shooting it back at you, that's bad.
So do you have the shield, you have your full body shield?
No, I mean, if you're doing something dumb, yes. If you're aware of what this thing's doing, no. I mean, the intriguing part is this cone of light coming out, it's expanding. So like, if you put your hand behind the cone of light, you will shoot your hand with a 1500 watt light bulb in a pretty small spot. Because the light's going someplace. So if it's not absorbed by the surface, it's bouncing off and going in whatever direction it's going in. So yes, this thing is problematic. I'm the one who's used it here anyway. It's got a lot of safety difficulties, so I'm only running it at night when there's somebody else here. And in order to run this thing, we're gonna have to, if we want to do it, otherwise it's gonna have to have an interlock on the door. Because we need if the door opens, the thing needs to be turned off. Because it's totally unsafe. It's really interesting and it's got a lot of really cool things it can do, but it has a lot of hazards that are not obvious, like you can't see the light that's flying around the room. So that part's not as fun.
Is this pre-market or are they in the market?
No, these are sold. We bought this about a year and change ago. It's about $5,000 with shipping. So I don't know, what are we up to now for tariffs? 35%? They're gonna be more tomorrow?
No, they're rescinded tomorrow.
Okay. Oh, cool. All right. Yeah, that's right. I forgot. It's usually like on 2 days, off 2 days. Anyway.
Is that used or new?
That's new.
Or new.
So, is
Yeah.
it like a China
For
one?
delivery.
Yeah. There, as far as I know, no one in the US is making these, which is the other lunacy here. Like nobody's gonna spool up and start making fiber laser supplies in the US. It's not a thing that's gonna happen anytime soon. So yes, these are gonna be imported. The head here can do cleaning, in this case, welding, and then a very similar configuration does cutting. And so you can use it as a cutter as well. It'll cut probably like 1/2 inch steel, I bet. The 500 watt one is supposed to do 1/4 inch, so this should be more than capable.
How clean would this cut in theory?
With
Like,
you or I cutting, not very clean. With
Yeah,
the CNC cutting, really clean.
I have a 60 amp plasma cutter, I mean, I don't,
Yes.
you know,
Yeah.
it's good.
Yeah. No. If you have a CNC running it, it cuts amazingly well. It's very clean. Other questions, Scott?
No shield gas?
I was running argon. I don't know that shield gas is actually required.
Okay.
It's the same.
You definitely need something to keep the optics clean. But I think nitrogen would probably be equally as good as argon, unlike regular welding that needs argon.
This does 2 minutes.
And I just wanna say,
You want those?
the 2 pieces you did, like,
2
people should realize that would be basically impossible to do with any other welding process that I can think of. Like, I don't know how you'd do that, the minimum piece of that.
Yeah, they're super thin. Dean?
Lasers, welding, been around 50, 75 years.
Probably.
Why
Yeah.
am I being naive and thinking, how come this wasn't in the market 25 years ago?
This has been around for a long time, but specifically only on optoelectronics. Talking like waveguides for fiber optic sources, things like that. They would do for the laser assembly, like to make optoelectronics, they would use fiber lasers for welding internally on the chips and stuff. So it's been around a long time for really specialized stuff, super expensive, like multi-hundreds of thousands of dollars for the system to run. Our granite slab table in the welding shop is an old fiber laser optoelectronic cabinet top. And they have 6-inch granite slab for the precision required for the alignment for what these things were welding. Not this welder, but a welder we bought surplus that we're playing with.
Good answer.
Any other questions? All right. Introduction. Who are you? Ready, set, go.
Craig, member of
Hey.
Sector67 for a couple of years, I like to do woodwork.
Can you repeat that?
I'm Craig, I like doing woodworking,